So what's next? I would like to expose my containers. Instead of just running a ping command, I would like to run a web service and connect to that web service. All right, so I'm going to use a small demo app, not the whole Docker Coins thing. I'm going to use a small demo app that has a web server. Okay, let me get that out of the way. So kubectl create deployment, and I'm going to call that deployment blue. You don't have to call it blue, but I ask that you use you can use one of the colors for which we have emoji circles. So red, green, blue, yellow, purple, white, black. That's fine. Okay, create deployment blue -- image jpetazo/color. So I do that, and seconds later I get a blue pod, which is in container creating state. A few seconds later it's running, and now I can connect to that pod. So my pod is 10.36.01. Okay. Let's do like this. Yes, perfect. So now I can do curl 10.36.01, and yep, that you can see this is pod default blue blah blah blah, and there is a little blue circle in frod of it. If you call the deployment green, you get a green circle. If you put red, you get a red circle, etc., etc. As long as there is a circle like this in the emoji character set. Okay, so let's pretend that this is some API backend or whatever, and I'm sending a bunch of requests to it. So I'm going to do while sleep 0.4 do curl done. I'm just sending a bunch of requests. Okay, perfect. Now, let's say that something bad happens to that pod. So something bad being somebody deletes the pod. Delete pod blue. So good news, bad news. Good news, I get a replacement pod right away. Within seconds, I get a replacement pod. That's awesome. Bad news, that new pod has a different IP address, and so my code here is broken. I need to stop it, and I need to restart it with the new IP address, which is not great. Plus, I don't know if I want to hardcode IP addresses in my code. That doesn't seem like a good idea. So I want to do better. And how can I do better? Well, we're just about to talk about services. So I'm going to create a service. How can I create a service? There is an easy way to do it with the kubectl expose commands. How does that work? I do kubectl expose. What do I want to expose? A deployment. Which one? Blue. And if I do that, it's going to tell me, hey, I'm sorry, you need to give me the port number. And I'm like, okay, fine. The port number is port 80, since that's an HTTP service on the default port 80. So I pass -- port 80, and it says service blue exposed. Okay? Now if I do kubectl get services, you can see that I still have my Kubernetes service, but I also have a blue service created like 7 seconds ago with a cluster IP. Now guess what? I can curl that cluster IP, and that works. Okay, so up there, instead of connecting to the IP address of the pod, I'm going to connect to the IP address of the service. All right, so far so good. Now let's see what happens if I delete the pod. So see how we had like one short little glitch. I'm going to zoom this and pause. One short little glitch when I deleted the pod, but seconds later, we recovered and traffic is now handled by the other pod. See, all these requests are served by pod GRZVN, and all these are served by NKPG4. All right. So the service, in that case, acts a little bit like a static IP address, like a fixed IP address. You know, I just have to connect to the cluster IP and it works. It doesn't matter what happens to the pod behind that. Now, let's see what happens if I scale up that blue deployment. So kubectl scale deployment blue, and I say I want 2 replicas. Okay, so within seconds, I get another replica here, and I don't know if you noticed, but immediately in the output here, this is when we scaled. Now you can see that my requests are load balanced between the 2 pods. In the beginning, I only had that pod, NKPG4, and now I have a mix between N2GQV and NKPG4. You can see that this is not like a perfect round robin with, you know, left, right, left, right, left, right. This is more like a few requests there and a few there, etc. But on average, this is a 50-50 load balancing. And of course, that's for 2 pods, but if I want to scale even more, you know, 3 replicas, it's going to create an extra pod immediately and add it to the load balancer right away. Okay, nice. Now, even better, because this solves my problem of what happens if a pod goes down, etc. I'm like, yeah, now instead of hard coding the address of the pod, you put the cluster IP, and that's better. Except I still don't want to hard code IP addresses in my code, like 10.106.88.5. Like, what is that? I don't want that in my code. Well, I could use DNS. And to do that, for this demo, I'll go on the other cluster, and I'm going to also kubectl create deployment blue image jpetazzo / color -- replicas 3 -- I wonder if I could directly expose it or something. No, that won't quite work. So, okay, let's create deployment blue. Then let's expose deployment blue. Now I'm going to do, I don't even need to do kubectl get svc to get the cluster IP. I'm going to do it anyway so that we can confirm, yep, now I have a blue service with this cluster IP. But now what I can do is curl blue.default.svc, and boom, that works. So now in my code, I don't even need to hard code the cluster IP. I can just put the name of the service, dot the namespace, dot svc, or if I'm in the same namespace, I can also just put the name of the service. That we will see that a little bit later. Okay, so that's how it works. So that's my cluster. I have a green service and I have a bunch of pods here, and what I can do is connect directly to the cluster IP, and I have something that will take care of the load balancing to the backend pods. If you're curious, the something could be something like kubeproxy, kuberouter, Cilium. I put a list here because we have multiple available implementations for this load balancing. So by default, out of the box on most clusters, this is kubeproxy. But if you want, you can replace kubeproxy with something else. Now, instead of connecting to the cluster IP, you can connect to the name. And when I say connect to the name, it means that we do a DNS resolution and then we connect to the resulting address. And DNS, again, in most clusters, it will be handled by core DNS, but you could also replace it with something else if you have specific requirements. Now, what about traffic coming from outside the cluster? What if I want to connect to this blue service, but from outside? This is a cluster IP, so it's not reachable from outside the cluster. You know, if I try to curl this, it's going to time out. But as you might guess, you know, if you look at this kubectl get SVC, you see that there is an external IP. So you might be thinking maybe there is a way to get an external IP from my service, and you would be absolutely right. So this is how we will make the difference between internal and external services. For an internal service, I just do, you know, kubectl expose, and I get a cluster IP. For public-facing service, I need to have an external IP. How do I do that? Well, I'm going to do a little demo. Let's create the red deployment, and let's expose the red deployment, expose deployment red, and I'm going to add --type load balancer, uppercase L, uppercase B. If you wonder why do we have --type load balancer, hold up just a few minutes, I'm going to explain everything about it, but let's see it in action. Okay, so first I want to do watch kubectl get services. Right, let's do this. Go. So I have the red service type load balancer, and this implementation of Kubernetes is ridiculously fast when provisioning external IPs. What I was expecting is that here in external IP, we would have seen pending, and it would have been pending for maybe 5 seconds, 10 seconds, and then we would have seen the IP address. I was not expecting that it would immediately showing the IP address, so keep in mind that usually it takes a little bit more time. But we have an external IP. Well, first, I still have internal load balancing. You know, if I connect to the cluster IP here, 10.128.37.156, that still works. So now it's the red pod, so I have a red dot here. I can also use curl red.default.svc, that also works. But I can also use the external IP address. Great. And I can also use that from outside the cluster. If I try from here, yep, that works. If I try from my browser, whoops, nope, that's not what I wanted. Sorry, let's do it again like this. Yep, that works. You get like this big red thing. And again, we're going to see load balancing here. If I send a bunch of requests for I in sec20, do that, send a bunch of requests, and you can see again that we have a mix between these different containers. Okay, so see, internal services, you just have the cluster IP. External services, you also have an external IP.